Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. So in today's class, we will be trying to establish comparison between various Intel processors. As of now, it may be difficult for us to compare all the Intel processors. So for ease of comparison, here we have considered three notable Intel processors, which are i3 8th generation, i5 8th generation, and i7 8th generation. Now these three microprocessors are being compared across various aspects. The aspects includes first one is lithography, then we have number of cores, then we have number of threads per core, then we have processor's base frequency, then we have max turbo frequency, followed by cache, followed by bus speed, followed by Intel Turbo Boost technology, followed by thermal design power, followed by max memory size, followed by memory type. Then we have max number of memory channels. Then eventually we have max memory bandwidth. So these are the 13 parameters across which these three processes are being compared. So before starting the comparison process, let us try to understand what does the individual aspects refer to. Now, lithography. Lithography basically refers to the semiconductor technology that has been used in order to manufacture an integrated circuit. Again, I repeat it. Lithography basically refers to the semiconductor technology that is used in order to manufacture the integrated circuit, and it's often referred in a unit that's called as nanometer. Now, it's an indicative of the size of the feature built on the semiconductor. Now, the next feature aspect of interest that we have is number of cores. So, core, as we all know, is a hardware term that describes the number of independent central processing unit that is present in a single computing component. Right again, so the number of central processing unit that is present in a single computing component will be referring to the number of cores. Now, third one, we have number of threads. A thread or a thread in execution is a software term that is used for basic ordered sequence of instruction that can be passed through or processed by a single CPU core. Right again, so a core may have multiple threads in it. Likewise, processor's base frequency. So processor base frequency describes the rate at which the processor's transistor open and closes. The processor base frequency is the operating point where the thermal design power is defined. Frequency is typically measured in a unit that is called as Hz, and it's often represented in gigahertz or billions of cycles per second. Now, max turbo frequency. Max turbo frequency is the maximum single core frequency at which the processor is capable of operating using Intel Turbo Boost technology, and if present, the Intel Thermal Velocity Boost. So max turbo frequency is the maximum single core frequency at which the processor is capable of performing operation using Intel Turbo Boost technology. Now frequency again we know is measured in terms of hertz and it's often represented in terms of gigahertz, or billions of cycles per second. Now cache. Now cache, as we all know, is a high-speed memory that is used in order to supplement the CPU registers. So CPU cache is an area of fast memory located on the processor. Now Intel Smart Cache refers to architecture that allows all the cores to dynamically share and access the last label cache. So this is very much important for you to understand that cache is a memory that is used in order to supplement the CPU registers and are capable of holding frequently used data. So it may be onboard or offboard cache depending upon whether it's internal or external cache. Now bus speed. Now a bus, as we all know, is a subsystem that transfers data between computer components or between computers. So this is a very important aspect that one needs to understand. So a bus is a subsystem that's capable of communicating data between computer components or between computers. So type includes front side bus, which carries data between the CPU and the memory controller hub. Direct Media Interface (DMI), which is a point-to-point interconnection between an Intel Integrated Memory Controller and an Intel I/O controller hub on the computer's motherboard, and a Quick Path Interconnect. So, which is a point-to-point interconnect between CPU and the integrated memory controller. So these, just see, these are the different types of buses that you can have, right? Okay, so again, I'll try, I want to revisit it. So a bus is a subsystem that is used in order to transfer data between the computer's component and between computers. So the type includes front side bus, right? Okay, direct media interface and quick path interconnect. Now, likewise, we have Intel Turbo Boost technology. So it is the frequency. It is the frequency is that is the maximum single core frequency at which the processor is capable of operating using Intel Turbo Boost technology. Right? Okay. So it's the maximum single core frequency at which the processor is capable of operating using Intel Turbo Boost frequency. So again, we know that frequency is represented in terms of hertz. So here. Very often it's represented in terms of gigahertz, that is billions of cycles per second. Now TDP, that is thermal design power. So thermal design power represents the average power in watt the processor dissipates when operating at base frequency with all cores active under an Intel defined high complexity workload, right? Okay, so TDP or thermal design power basically represents the amount of power that the processor is capable of dissipating, right? Okay, while operating at a base frequency when all the cores are active under Intel defined high complexity workload. Now, max memory size. Max memory size basically refers to the maximum memory capacity supported by the processor. So, max memory size basically refers to the maximum memory capacity supported by the microprocessor. Now, memory type. So, Intel processors come in four different types. So, a single channel, dual channel, triple channel, and a flex mode, right? Again, so this is what memory type basically refers to. Now, maximum number of memory channels, right? So here, the number of memory channel refers to the bandwidth operation for real world application, right? Again, so this is what maximum number of memory channels refers to. So number of memory channel refers to the bandwidth operation for real world application. Now, max memory bandwidth is the maximum rate at which the data can be read from or stored into semiconductor memory by the processor. Now, this is what is max memory bandwidth. So, max memory bandwidth, again, I'll repeat it, is the maximum rate at which the data can be read from or stored in a semiconductor memory by the processor. So these are the notable 13 aspects across which we will be trying to compare the three Intel processors, which are i3 8th generation, i5 8th generation, and i7 8th generation Intel processors. Now, lithography, in case of i3 8th generation, it is 14 nanometers. In case of i5 8th generation, it is 14 nanometers. And again, in case of i7 8th generation, it is 14 nanometers. So, lithography across i3, i5, and i7 8th generation Intel processors are 14 nanometers. Now, likewise, number of cores. So, i3 has 2 cores, i5 has 4 cores, i7 also has 4 cores. Number of threads, i3 has 4 threads per core, whereas i5 has 8 threads and i7 has 8 threads per core. Now, processors base frequency. So the frequency for i3 8th generation is 2.2 gigahertz, whereas for i5 8th generation it is 1.5 gigahertz, and for i7 8th generation it is 1.9 gigahertz. Now, max turbo frequency. So max turbo frequency in case of i3 8th generation is 3.4 gigahertz, whereas in case of i5 8th generation it is 4.1 gigahertz, and i7 8th generation it is 4.2 gigahertz. Now, likewise, cache. So i3 8th generation has 4 MB smart cache, right? i5 8th generation has 6 MB of smart cache, and i7 8th generation has 8 MB of smart cache. Now, bus speed. Bus speed, For i3 it is 4 GT, that is billions of transfer per second. In case of i5 8th generation it is 4 GT, and in case of i7 8th generation it is 4 GT. So here GT stands for giga transfer or billions of transfers per second. Now Intel Turbo Boost technology, right? Okay, so here we have 3.4 gigahertz in case of i3 8th generation. We have 4.1 gigahertz in case of i5 8th generation, and we have 4.2 gigahertz in case of i7 8th generation. Now TDP, that is thermal design power, or the amount of power dissipated whenever the processor is operating at base frequency. So TDP for i3 8th generation is 15 watts, whereas for i5 8th generation is 15 watts. Likewise, for i7 8th generation it is 15 watts. Now, maximum memory size. So maximum memory size in case of i3 8th generation it's 32 gigabytes, right? In case of i5 8th generation it is 64 GB. Likewise, in case of i7 8th generation it is 32 gigabytes, right? Again, now memory type. So we have DDR4 in all the three types of processors. We have DDR4 being used in all three types of processors, that is i3 8th generation, i5 8th generation, and i7 8th generation. Now maximum number of memory channels. So we have two number of memory channels in i3 8th generation, i5 8th generation, and i7 8th generation respectively. Now maximum memory bandwidth, so it is 37.5 gigabytes or gigabytes per second. So it's true for all the three microprocessors, that is i3, i5, and i7 8th generation. So you see, this is a very simple cross attribute comparison of the different Intel processors. So if you want, you can establish you can include more number of processors into this comparison table, and you can make it much more elaborate. So but for now, here what we have done is we have compared three Intel processors, that is i3 8th generation, i5 8th generation, and i7 8th generation across 13 notable aspects. So again, I'll repeat it here. The aspects are lithography, number of cores, number of threads, processor's base frequency, max turbo frequency, cache, bus speed, then Intel Turbo Boost technology, then thermal design power, then maximum memory size, memory type, maximum number of memory channels, and maximum memory bandwidth. So here what we have done is we have taken into account 13 aspects across which we have compared three processors. So thank you very much. Have a very nice day.